All right, let's determine the intervals of concavity for the following function. So if we want to look at intervals of concavity, we need to find the second derivative. We're effectively employing the second derivative test. So in order for me to do that, I'm going to find the first derivative, f prime of x, which is the derivative of my function f of x to the power 4 minus 6x squared plus 10. F prime of x here is equal to 4x cubed minus 12x. And my second derivative, f double prime of x here, is equal to the derivative of my first derivative, 4x cubed minus 12x, which is basically 12x minus 12. Okay, so my second derivative function is what I'm going to be working with, 12x minus 12, right? And in this case, 12x squared minus 12. Sorry about that. 12x squared minus 12, and in this case, in order for us to determine our intervals of concavity, what we need to do first is we actually need to find our point of inflection. So our point of inflection is where we have a change in concavity, right? You can actually use the point of inflection as a benchmark to determine the intervals. Now, in order to do this, the point of inflection occurs when the second derivative function, f double prime of x, is equal to 0. So I'm going to let f double prime of x equal 0. You get 12x squared minus 12 is equal to 0. I'm going to move the 12 to the other side. 12x squared is equal to 12. I divide by 12 to both sides. X squared is equal to 1. If you want to solve for x, I'm going to do the square root. Okay, the square and the square root cancel out. And x is equal to plus minus 1. Okay, now these are the points where our point of inflection occurs, right? That f double prime of negative 1 is equal to 0, and f double prime of 1 is equal to 0. Now to actually find the point of inflection, right, to actually find the point of inflection, you need to plug this into your original function. So we know that our point should be negative 1 and f of 1, and 1 and f of 1, right? Negative 1 and f of negative 1 and 1 and f of 1. Now, if you actually plug in f of negative 1 into the function, if I plug it in for x, you actually will get 5, and you can notice that you'll get the same value for 1. Okay, so therefore the point of inflections are negative 1 and 5 and 1 and 5. Okay, so those are our point of inflection, but now we need to figure out our interval. So what I'm going to do here is I'm going to create a number line. Okay, so this is my number line. And what I'm going to do is I'm going to plot my 2 points of inflection. So this is negative 1, and then this is positive 1. Now you can notice here that these are basically open circles. Okay, so these are open circles. And we can actually gauge the intervals, right? So one of the intervals here is negative infinity and negative 1. So it should not include the point of inflection, because the point of inflection is when we have a change in concavity. The other interval is negative 1 and 1, and the other interval here is 1 and positive infinity. Okay, so let's test each of these intervals, right? So I'm going to do, let's start with this interval between negative infinity and negative 1, and I'm just going to let's use this in a different color so we can kind of differentiate. So I'm going to let x equal, let's do negative 2. Okay, so let's do f double prime of negative 2, right? And you're plugging this into your second derivative function, not your original function, right? So if I do f double prime of negative 2, this is going to be 12 times negative 2 squared minus 12, which is definitely going to be, so you can already kind of tell, it's 48 minus 24, minus 12, sorry, is greater than 0. So if f double prime of negative 2 is greater than 0, this is going to be concave up. So between negative infinity and negative 1, it's concave up. Let's take a look at the next interval between negative 1 and 1. Okay, so I'm going to test out f double prime of 0. If you do f double prime of 0, if you plug this in, you get 12 times 0 squared minus 12, right? So you can see that f double prime of 0 is less than 0, so this is going to tell us that this portion here is concave down, right? And then for the last interval between 1 and positive infinity, I'll just use red. For between 1 and positive infinity, I'm going to test f double prime of, let's do 3, right? If you do f double prime of 3, you get 12 times 3 squared minus 12, which is 108 minus 12. So this is definitely greater than 0, and this portion here is concave up, right? So therefore we can determine here that therefore the function, and we'll call it the function f of x, therefore f of x is concave up when x belongs to negative infinity and negative 1 union 1 and positive infinity. Okay, so between these intervals the function is concave up, and it's concave down when x belongs to negative 1 and 1. Okay, so this is basically our intervals concavity for the function f of x.